Hello everyone, I'm Michael Wybrow, and in this video I'm going to talk to you about core location. So core location is the framework that we use to access the GPS and the compass sensors on iOS, and it can give us information on the location and the heading of a device. There's two different ways that we can utilize core location. We can receive updates after the device has moved a certain amount, typically a small amount, or we can get more coarse-grained updates where we receive them after the device has moved a significant distance. In addition to this, as an alternative to listening for events, we can also just ask core location for the current value of things, and that's what we call polling. So you can do that as a more manual process. In terms of permissions, iOS will check at runtime for location permission. Obviously, even if the user grants a permission, the next time the app runs, or as they're using it, they might have gone to the settings app and turned off this permission. So this is something you need to be aware of. In order to access the location the first time, you need to specify what the location will be used for. So this information gets displayed to the user in an alert prompt when your app first requests access to the location, and they have to approve it. How you do this is by adding values to your info.plist file, and there's particular keys that you need to use for this: NS location always and when in use, usage description, or NS location when in use, usage description. So these are two different situations, one where your app needs background and permission when in use, and one that it just needs location information when it's in use. And each of these is just a string value. You would say something like, this application makes use of the GPS sensor to show how it works. And that's an example of that. Okay, so how do we access the location? We do this through an object called a location manager. We do this by creating an instance of the CL location manager, and when it detects an update, it will call a method on its delegate. So again, this is the standard delegation pattern. You set yourself up as the delegate to a CL location manager, and your class gets called with the updates. So to do this, you need to your class needs to adopt the CL location manager delegate, and then to start off this process, to trigger updates to begin, you need to do one of the following based on our points on the previous slide. You either need to say that you want to start updating location, or you want to start monitoring significant location updates. This is the more coarse-grained one. As part of doing this, when we use the start updating method, you must specify some additional settings. One of these is distance filter. Distance filter is how much distance needs to be moved before the delegate is informed of a new update. And this is something in meters. So let's say you want updates every 10 meters, you would say location manager.distance filter equals 10. The smaller the value, the higher the frequency of updates, the higher the drain on battery life. So the general rule is use this as little as you can, because otherwise you're going to decrease the phone's battery life. We can also suggest a desired accuracy, and this depends on the type of app you're doing as to what kind of accuracy you care about. So, and obviously the higher the accuracy, again, the higher the battery drain. So some examples for these constants are accuracy best for navigation, accuracy best, accuracy nearest 10 meters, 100 meters, kilometers, 3 kilometers. So you can imagine different types of apps and what they care about. Okay, so core location. Regular updates. How do you do this? We create an instance of the CL location manager. Then in our view did load, we set the desired accuracy, the distance filter, set up ourselves as the delegate, because otherwise we won't even get notified of anything. And we request either authorization for while in the app or always authorization. And this triggers the prompt to check that we have authorization. When you have authorization, you want to start updating the location. You want to do this in the view will appear. Like if you've got a map view and you want to track the location, user's location on it, or some other view, you only want to do this when you actually need it. So we would turn it on when the view will appear. When the view will disappear, we would stop updating the location. Then this is the delegate method. So like all of Apple's delegation patterns, the first thing it does is pass you the specific location manager that triggered this. So you get called with location manager, did update locations, and you get an array of CL location objects. And you can check that that array is not empty, just take the last value of it, and then we take the current location is the location.coordinate, and location coordinate just has a longitude and latitude value. So the other method of location updates is significant changes. You can't predict the timing of these ones. As the documentation says, apps can expect a notification as soon as the device moves 500 meters or more from its previous notification. It should expect notifications more frequently than once every It should not, expect notifications more frequently than once every 5 minutes. And if the device is able to retrieve data from a network, the location manager is much more likely to deliver notifications in a timely manner. So if you need only very coarse-grained location data, this is a great way to do it with less processing power and less drain on battery life. The process for doing this is instead of the start updating method we called before, it's start monitoring significant location changes and the equivalent stop monitoring significant location changes. I want to talk for a minute about handling location in the simulator. So if you've got a physical device, this is a lot easier. If you have to use the simulator, well, our Macs that we develop on don't have an onboard GPS or compass sensor, so that means that you're simulating these values. Luckily, the iOS simulator at least provides a way of simulating GPS behavior and location, both stationary and moving. So Xcode has some default locations built in, but you can also specify additional ones via a GPX file, and these files give one or additional locations that the simulator can use to simulate a device location over time. So the iOS simulator has some built-in, let's say, simulated movements. There's a bike ride that starts out at the Apple campus, there's a freeway drive, there's I think a walking route, and there's a bunch of fixed locations. Also, with our kind of bar at the bottom when our app's running where we can override things like our dark mode, there's also a way of overriding and simulating the location. And these are just some fixed locations that you can add in, and the app will see them as changes to the location. So let's talk about compass sensors. So compass sensors are in all recent iPhone and iPads. This allows the direction of the device to be determined and gives you a facing relative to magnetic north. The process is super similar to location tracking. You also use CL Location Manager, but there's a different method you use, start updating heading. And you get back a value that's between 0 and 360, an angle. 0 is due north, 90 is east, etc. And the delegate method that will be called as a result of start updating heading is location manager did update heading, and you get a CL heading object. Finally, geofencing is a way of watching for a device entering or leaving a particular barrier area. So it uses data from sources such as GPS or RFID. So again, like this framework behind the hood uses a lot of different sources for location information. And you can get updates when you enter or leave a region with a fixed radius. So you must have permission again, and iOS can track up to 20 of these geofenced regions. Obviously, there's costs associated with it because you're having to periodically check the location information. The kind of way this is used, if you've ever set a notification via Siri where you've asked it to remind you of something when you get to work, or remind you when you get home about something, or an app that receives information, say on a flight when you arrive at the airport, or if you visit an Apple store, you'll get a notification saying it knows you've arrived at an Apple store, all that kind of stuff. So here's an example of how you would do geofencing. We create, we have a CL circular region that represents our geofence basically. We have our location manager as before. In our view did load, we could create an annotation, which we'll have a look at a little later. We can create a CL circular region that's centered on a particular coordinate. It has a particular radius, and we can give it an identifier. And we can say notify on exit from that region. Then we would set ourselves as a delegate. We would request authorization, and we would start monitoring for a particular one of these CL circular regions. Then via the delegate callback, we would get notified when this happened via the location manager did exit region, and it would give us the CL region that we'd exited. Then we could do something like show a UI alert controller and say you've left Monash Caulfield. Okay, thanks for watching.